പദമിതീശ.
जनयित्री जय जय विज्ञान साम्राज्य जय जय विद्या जनयित्री जय जय विज्ञान साम्राज्य जय जय विजय संधात्री जय जय यावत् प्रपंच.
There is no iota of doubt that research plays a significant role in shaping the mind of learners and thus developing any nation. In the fast-changing world, the needs and strategies of learning have been progressively changing, especially after the advancement of technology in the arena of organocatalysis.
This event aims to provide a platform to aspiring master and doctoral students, especially for postdoctoral chances and scientists and faculty members of varied disciplines to interact with experts from India and France.
So Department of Chemistry has 26 faculty who has graduated PhD from all over world, and 70% of faculty has foreign exposure either in the form of postdoc or a PhD program. And we have completed 5 PhDs so far, awarded degrees, and around 100 PhDs are ongoing in our department.
Why it is important? Because the field of organic catalysis, the award, Nobel Prize awarded is awarded in 2021. That's why it is the modern trend. Every chemist is concentrated on this.
Indo-French international seminar. And as you know, India and France are strategic partners in many areas of science and technology. So this seminar, definitely the next 3 days, is going to be an eye-opener and a lot of learning experience to each one of us. I wish this seminar a grand success. Welcome each one of you to this university once again. Thank you so much.
This event has given me 2 important things to talk. Number one, my own association with the Indo-French Center. I was very active with all Indo-French activities during the end of previous century and at the beginning of this new century. I had organized one such similar workshop, but not in India. It was conducted in Paris. This inauguration took me into that nostalgic period. I wish all the success. I'm very sure when pioneers are over here, other than success cannot be possible at all.
Although CEFIPRA, I was never part of Indo-French thing, but I'm always admirer of France and also the friends in France, because several times I have got Schengen visa long term with the help of this country. And I happened to meet Nitin here, and while looking at him, my mind is saying I had met him several times, but not able to recall where and all that. But that's not important. There are so many people, Ramachari, Nitin and several others are here. And when you travel, you get chance to meet all of them. So I convey my best wishes, and I'm sure the conference is going to be very successful. Thank you.
You know, we are the lowest cost producers of medicines in the world, wherein we are pioneering in terms of generic medicines manufacturing. But what about APIs? I'll mention my experience of first time when I bought an Essilok tablet, which is ranitidine tablet in Germany. You know, my headquarter was Bonn, and I did my postdoctoral from France, but it was the first experience of Germany. The same experience is there in France, but next time I learned from my own mistakes. Why the APIs are costly? So the pertinent question which the science has to find out a low cost solutions for a high quality, low volume manufacturing. Because India is actually a dispersed country. If I am talking of a geometry of India, you cannot have a single place manufacturing. For example, the Lay's, Picnic and Perks and the chips which we eat in France, the lowest SKU, which we call it as stock keeping unit, is a big size, which is 2 euros in all. In India, we work on 5 rupees. Less than
It's very old, published paper in 1971. And we have a sugar-based organic molecule for, if you know epoxidation reaction, you'll see that this is very good organocatalyst for epoxidation. Of course, Macallan, this kind of imidazolidone catalyst for Diel soda reactions.
So in our group, so we work mainly on catalysis. So we work previously, a long time ago, also on water, catalysis in water. We could obtain it as 79%. This is without HFIP, so no rearrangement. If you had HFIP, then you can make the rearrangement.
First of all, an overview of what we've done a few years ago, and then I've been focusing on only one small story. Today I wanted to focus on this small story. And this story is quite old, and it relies on cation reactivity.
We working on last 20 years continuously on organocatalysis and understanding about the kind of coupling reaction.
Our photoredox catalysis, which is very famous in organic chemistry, which started with ruthenium tris bip by Macmillan. And you can use it in organic solar cells and also fluorescent sensors. But the main ingredient of all this is, actually photosensitizer.
We designed some copper complex, so this is the best complex from the literature that we screened, and it gave us 52% yield. Potassium carbonate, it's basic enough to generate hydroxide in the presence of B2Pin2. Okay, because this is a Lewis acid. The proton is.
The gold catalysis based on this particular pillar we call as a carbophilic activation, and what it usually involves is the activation of CC multiple bond by either gold 1 catalyst or by gold 3 catalyst, and you have such a kind of a carbophilic activation.
So our idea on this reaction is to study the propargyl Claisen rearrangement beyond allenes, and then as a result what you get is a direct access to cyclized products, and At the same time, we don't want to start from the propargyl ethers. We wanted to in situ make the propargyl ethers and thus to lead to the cyclization products.
Of course, we always actually get inspiration actually from nature, right? Actually, nature knows actually how to do things actually in a very sustainable way, right? Because the process has to go for a longer period of time. And if you actually work with something which is
so it's not catalysis, but it can fit the principle of green chemistry as it offers a nice way to generate radicals under a mild reaction condition, because it's used.
So development of methods for the eradication of these type of pollutants from aquatic system is the need of the era, and many techniques are used, and among the various techniques, the adsorption and membrane filtration are efficient. But after the adsorption and after the filtration, what we will do with these pollutants?
So if you look at the reactions of N-heterocyclic carbenes, we know that catalysis is one of the sustainable methods for forging carbon-carbon bonds. So if we use various catalytic techniques starting from enzyme catalysis, transition metal catalysis, and the third important area, the organocatalysis, where the small organic molecules can help in forging carbon-carbon bonds.
We wanted to mimic this galactose oxidase, which is having copper in the active site. So there are so many models reported in the literature, but most of them are either achiral chiral copper complex or racemic one. Being as organic person, particularly the asymmetric synthesis person, what I thought, when the enzyme has a copper in a chiral environment, why don't you make a chiral copper complex, that is galactose oxidase enantiomerically pure model.
రాచిలక నువ్వే కావాలి, నా రాచిలక నవ్వే కావాలి, రాగాల మువ్వై రావాలి, అనురాగాల మువ్వై మోగాలి.
The reported method, let's say you are doing asymmetric halogenation. There is one problem. What is the problem? Once the halogen got transferred to alkene, these halonium ion, it can undergo exchange among them. So when they undergo exchange, you lose the enantioselectivity. Of course, that is our end goal, to develop asymmetric new chiral catalyst. So the weak interaction is also issue, and catalytic stability is also problem, like when you have a phosphine type and they sometimes melee, and if we can develop phase transfer catalyst also in a solvent like heptane, that will be really fantastic. That was how we started our project in maybe 5-6 years before.
So mainly my research focusing on the protein folding, unfolding studies in the presence of the greenery solvents, ionic liquids, diuretic solvents, and protein folding, unfolding studies in the presence of nanoparticles, polymer phase transition. So in that polymer and protein interactions, composite formation between polymer and nano particles. The last one but not least, protein stability in the biomass. So at the moment we are working in these areas, different areas in biophysical laboratory.
CF3 motif specifically has two contradictory properties. The first one, high electronegativity, and the second one related to high lipophilicity. And you can see the CF3 motif is contributing to address major societal health issues, like with this anti-diabetic, one of the top 20 most sold drug, Thalassemia and anti-cancer, and more recently to treat AIDS, or even Paxlovid to treat COVID-19, that all over the world we suffered with this stuff.
We work on tuning the structure of novel solvents, and we tune the structure to get the targeted property or the combination of properties, bulk properties, and then we need this kind of properties or the combination of the properties to achieve the desirable applications. So we design new ionic liquids, deep eutectic solvents. We study their different combination with different polar and non-polar solvents, aqueous solutions, and then we use their extensive study of thermophysical properties, phase equilibria, and then we use this data for structure property correlation or structure property composition correlation, and also we do reverse designing, and then we use this for the targeted application, or W2W, where it's waste to wealth or benign separation and so on.
So what is the problem if we use transition metals? So at the end of that reaction, there is a waste of halide waste during that reactions. To overcome this organocatalysis came into the picture, right? So if I request all the MSc students, or if any research scholars or any BSc students are here, so you please attend these type of seminars. So in future, if you know any nearby universities or other universities, you go and attend. Because if once if you take the paper and if you read, you cannot find all these things. You can see the picture. So here you saw that FTIR spectrum and NMR spectrum and some lifetime spectrums you can see in the paper, but you don't know while reading that paper. So if you come and attend these type of seminars, so this is like a catalytic process. So what catalyst will do in the reaction, it will increase the rate of reaction, right? So if you attend these type of seminars, so it will increase your rate of study and rate of understanding the research and what area the people are working, in what area you want to work.
And they clearly explained about different organocatalysis and how to apply this organocatalysis for different asymmetric reactions. They also explained how to prepare this organocatalyst and the different mechanic aspects and substrate scopes, merits and demerits of this different organocatalyzed reactions. I strongly believe this seminar will initiate and motivate all the young researchers towards the organocatalysis and asymmetric organic synthesis.
Excellent speakers, and they have ignited and made excellent deliberations, and they justified all the things, the catalysis and the role in pharma industries.
That was a great honor. I would like also to thank all my French delegates who were keen enough to join us, and I think we have very high level quality of lectures and from both sides, and I think this is a very great opportunity that was only possible thanks to the CFIPRA. So I would like to send my best regard to CFIPRA for giving us such a unique pattern to have a chance to merge France and Indian researchers in the same place.
Indian convener and foreign convener, Dr. D. Nagaraju and Tatania Bassett, madam. Congratulations both of you for organizing such a wonderful 3-day international workshop. On behalf of the Department of Chemistry, I thank the funding agent, especially I think CIFRA and DST combined for providing such kind of international workshop.
A great experience for me today. So, first time in India, great hospitality, great science. So thank you all of you for attending here. Truly honored, and I hope that next time we could invite you in France and we organize also great meeting as you did here in India.
It's a great pleasure to be in India. As my colleague Anis said, we would like to have you all in France for the next symposium. The level is very high because we had great time, great food, great science, great everything.
All the people involved in the organization, that was wonderful. We had a great time. For science, it was amazing as well. Excellent speaker from both sides, India and France. And I'm pretty sure this symposium is now a stepping stone. So next time that's going to be in France, I think it's almost done. Okay, so this is something which is pretty important, and I'm pretty sure a lot of collaboration will come from this strong network that is now established, and that's pretty cool for the future. So
it's really been an exceptional experience to come to India. I now know, and I think we all know, what Indian hospitality means, and the level is really high, as my colleague was saying. So thanks to the organizer again, and for the hospitality of this university. And also it's amazing to see you all in this house and listening to the great science. So thanks to our colleague Indian side, it was amazing to discover all this nice chemistry and all this science and discussion, and also a part of that, the discussion out of the room were really great. So I hope to come back one day, and I also hope to see some of you in France.
I was really happy to be here, and thank you very much to all the organizers from India. You are very nice hosters, and your hospitality was very nice, and we had very wonderful lectures, and it was very enjoyable to share these scientific moments with you, and also the moments that we have during dinners and everything. It was really nice. So I hope that it will open nice the opportunity to continue to collaborate between each other, and of course you are welcome to come in France, and we are waiting for you.